Ah.
Okay. So, dimensional analysis, basically it is the process of converting between dimensions or units. And we do so using conversion factors. Last week we used the molar mass as conversion factor. whether that was an element or whether that was a compound. We've used Avogadro's number as conversion factor. Again, whether that is of an element or a molecule or an ion. We've used the mole-to-mole ratio from the chemical formula as a conversion factor that allows us to convert from one substance into an element within that substance. We've used, and today what we're going to do is we're going to introduce the metric to metric conversions, where we use the metric prefix system to perform conversions, and then on Wednesday we will add the English to metric conversions, where we convert between the English unit or the English system of units to the metric system of units. Basically, folks, all these different conversion factors, we've also got one more, well, a couple more after this. All these different conversion factors can be used individually, they can be used as a grouping, and use multiples in a row. So it's important that we take time to get to know our individual conversion factors so that we can then start to apply them. What I'm passing out now is a set of conversion tables. On the top is English to metric conversions, or is English conversions, and on the bottom is metric to metric conversions. You will receive the top table on an exam, but you will not receive the bottom table on an exam. To help you memorize the bottom table, I already have posted a Quizlet with metric to metric conversion factors in that one. So again, you'll receive the top table, but you will not be receiving the bottom table. Okay, so the very first thing I want to do is just take a moment to make sure that you understand how the bottom table is arranged. Let's say we're talking about grams. Then the way you interpret this bottom table is, for example, kilo. One kilogram is equal to 1 times 10 to the third grams. Or let's say we're talking about centi. 1 centigram is equal to 1 times 10 to the minus 2 grams.
So in other words, what I'm doing is I'm plugging in the unit in place of Z. Z in my conversion table is simply a placeholder for whatever the base unit is. So if talking about liters, for example, and we're working with milli, M, then 1 milliliter is equal to 1 times 10 to the minus 3 liters. Or let's say we're talking about mega, capital M, 1 megaliter, 1 megaliter is equal to 1 times 10 to the 6 liters. So again, what we're doing is if you look at the bottom table, I'm plugging the unit that they have in common, grams or liters, or it could be something else, in for Z. That's one thing you should note about this bottom table. The second thing that I would like you to note about the bottom table is that the prefix, which is the first portion of the equality, always has a 1 with it. 1 giga, 1 mega, 1 kilo, 1. The prefix always has a 1 with it. The unit by itself is always associated with the scientific notation. So that's how you can read that table. Now, how do you know if you will need the metric to metric conversion table? The answer to that is do the 2 units have something in common? Let's take this kilo one and talk about it a little bit more. 1 kilogram is equal to 1 times 10 to the 3rd grams. They have the term gram in common. And so that's telling me that it's part of the metric system. When I look at mega here, 1 megaliter is equal to 1 times 10 to the 6 liters. They both have liter in common. That's how you're going to know that you need the metric prefix system, is do they have a portion in common? Questions so far? So let's look at examples. It will be a one-step conversion when converting between the base unit and a prefix unit. What I mean by a one-step conversion is that means you're only going to have one conversion factor. So how many milliliters is in 103 liters? Just like before, we're going to start with what we were given. We were given 103 liters. We're going to identify what we want. We want milliliters. They both have the term liter in common. So unit in common. Means metric. And so looking at your metric prefix table, 1 milliliter is equal to 1 times 10 to the minus 3 liters. We start our calculation with what has been given, 103 liters. Our first conversion factor needs to have liters in it, so that's when we're going to be using our metric conversion. So 1 times 10 to the minus 3 liters is equal to 1 milliliter. Keying that into the calculator, you get 1.03 times 10 to the 5 milliliters. As far as significant digits go, this 103 has 3 significant digits. Metric prefix conversion factors have an unlimited number of significant digits. And so the one with the fewest was 3 significant digits. So that's why I put it in scientific notation so that I could have 3 significant digits. Another example. How many meters is equal to 10.3 kilometers? Start with what you were given, which is the 10.3 kilometers. Look at what you want to solve for, which is going to be meters. They both have meters in common. So that means unit in common means it's going to be the metric to metric conversion. If I look this up, 1 kilometer is 1 times 10 to the third meters. Starting my calculation with what I've been given, 10.3 kilometers. I'm going to place kilometers in the denominator. So 1 kilometer is going to go into the denominator. The other portion of the equality will go into the numerator. So 1 times 10 to the third meters goes in the numerator. The kilometers cancel and I'm left with meters. So I get 10,300 meters or 1.03 times 10 to the 4 meters. Both of those is correct because I didn't put my decimal point after the 10,300. Yes. Okay. Yes.
So when you put it in the calculator, how exactly put it?
How exact?
You're like, yeah, because I'll be putting the stuff in the calculator, I'll be getting different numbers. I don't know the way I'm putting it in there.
It's very possible that it's how it's being put in, because if you forget, if you're using the method of 1 times 10 carat, is that what you use?
Yeah.
Then don't forget your parentheses before and after it. Because see, if you, here's the thing. Let's say this 10.3. I mean, it shouldn't have mattered too much, but let's say we have 10.3 times 1 times 10 to the third. If you key it into the calculator this way, the calculator literally goes, okay, I'm going to multiply it times 10 to the third. So, or I'm going to multiply that. So that's 10.3 times 1. And then I'm going to multiply that 10.3 times the 10 to the third. So it does some weird stuff in a calculator. You've got to key it in if you're going to use this method where you use the times 10 carat. you've got to key it in as 10.3 times, open parentheses, 1 times 10 to the caret 3, close parentheses, or it will screw it up. And it's not you, I've seen it done a ton. Did it come out right? Yeah.
Like, even when we were doing the last thing that we were doing,
Mm-hmm. Same thing. If there is any scientific notation, all scientific notation has to be put in parentheses or it'll screw it up. It's how the computer inside the calculator reads it. Let's look at another. Let me give you one to do. Micro is the funky looking U, fourth up from the bottom of the table. It's actually the Greek letter mu. Yes,
so it's say -2.
correct. That was the answer. So the problem is 10.5 micrograms. 1 microgram is 1 times 10 to the minus 6 grams. So that comes out to be equal to 1.05 times 10 to the minus 5 grams when multiplied out. Don't forget your parentheses. Okay. Any questions about that last one? Did you get 1.05 times 10 to the minus 5 when it's keyed into the calculator? You can estimate what the exponent should be. And if you want to learn how to do that, come see me. I will show you how to estimate what the exponent should be if you are struggling. Okay, so that was one-step conversions. Now we're going to get to two-step conversions. And this one you're going to use when you convert between two prefix units. Step one will be to take the unit given and the base unit. Step two will be to convert between the base unit and the desired unit. Let's look at some examples. How many nanograms is equal to 75 kilograms? Start with what we were given, which is the 75 kilograms. Identify what you want to solve for, which is the nanograms. Now, these have grams in common, but they are two prefix units with those grams in common. Since there's two prefix units, you're going to have a two-step conversion. So what are your conversion factors? Well, the first conversion factor is going to be related to the kilogram, which is 1 kilogram is equal to 1 times 10 to the third grams. The second conversion factor is going to be related to what you want, which is nanograms. 1 nanogram is equal to 1 times 10 to the minus 9 grams. Once you've identified your conversion factors, you can begin the calculation. So 75 kilograms. Your first conversion factor has to have kilograms in it because it has to go into the denominator. So we're going to use the first one. And we're going to place the 1 kilogram in the denominator with 1 times 10 to the third grams in the numerator. You place the kilogram in the denominator so that the unit cancels, leaving grams. Now you're going to use your second conversion. And the gram portion has to go into the denominator. So 1 times 10 to the minus 9 grams is equal to 1 nanogram. The gram portion went into the denominator so that the units canceled. And now we're ready to perform the math. And when you get your answer, it's going to come out as 7.5 times 10 to the 13 nanograms. Questions? Yes.
How do you know when you need to put the, like, whatever, 1 times, whatever extra on top of it?
It all is based off of what unit I want to get rid of. So I'm not focused on the number. I'm focused on the unit. In this first one, I had started with kilograms. So the kilogram piece had to go in the denominator so that they would cancel out. The next one, and once those were gone, I had grams left. So on the next one, the gram portion had to go in the denominator so that the unit would cancel out and put the nanograms in the numerator. Did that answer your question? So it's all about the unit. It's not about the number that's associated with the unit. It's all about canceling the unit. Questions? There's two ways. Two ways to put this in the calculator, depending upon which, and it's really dependent upon which method you want to use. I'll do method one as the method that is frequently taught in the schools. This one would be 75 times, open parentheses, 1 times 10 caret 3, close parentheses, divided by 1 times 1 divided by open parentheses, 1 times 10 to the minus 9, close parentheses, equals. Don't forget a parentheses, though. Oh, excuse me. That's not time. That's caret -9. Equals. But don't forget a parentheses. Now, personally, I don't like this method because it's easy to forget parentheses. So method 2 is 75 times second, whoops. Seventy-five times 1 second, comma, 3, divide by 1 times 1, divide by 1 second, comma, -9. What that looks like in the calculator is it would be 75 times 1E3 divided by 1. Well, actually, it looks like that. Divide by 1 times 1, divide by 1E -9. Take your pick which one you do. Oh, and basically both of them got equal signs. Or enter, whatever. Other questions? Let's do one more. A 125 centiliters equals how many deciliters? Again, I notice they both have liters in common. So units in common means metric. For the first conversion but it's going to be a 2-step. Because two prefix units. The first one is going to be the one with centiliter. So 1 centiliter is equal to 1 times 10 to the minus 2 liters. And the second one is going to be the one with deciliter. 1 DAL is equal to 1 times 10 to the 1 liters. A 125 centiliters is where we will begin our calculation. The first conversion factor we need has centiliters in it, so it's going to be the first one. The centiliters have to go in the denominator, so the 1 CL is going to go in the denominator, while the 1 times 10 to the minus 2 liters go in the numerator. The CL had to go in the denominator so that it went away, leaving leaving L. The next one is going to have L in it, which is going to be our deciliter. Of that, the 1 times 10 to the minus 1, 1 times 10 to the 1 liter will go in the denominator, while the 1 DAL goes in the numerator. The reason the liter had to go in the denominator is so that it canceled, leaving DAL. And then keying this in, you get an answer of 0.125 deciliter. Questions? We will make, there's one more variation on the metric prefix conversions, which we will be doing on Wednesday, and it's the toughest one. And that is when you start cubing and squaring roots or units, what do you do? And we will do that on Wednesday, and we'll also get into the metric, we'll also get into this top table on Wednesday, which is your English to metric, English to English conversion factors. And how do you recognize when to use this table compared to when to use the metric table? Again, folks, the top table will be given to you on an exam. The bottom table you must have memorized. To help you with the bottom table and memorizing it, 2 things. Number 1, you will notice that they go 12, 9, 6, 3, powers of 3, 3 powers of 3, then 2, 1. And on the bottom, it goes 1, 2, 3, 6, 9, 12, but they're all negative. The other thing you will notice is at the very bottom of the sheet, I gave you a way to memorize them. And then I also have given you a Quizlet to help you along the way as well. So there's lots of ways to help you memorize this table. This one you don't have to memorize because there is no rhyme or reason. And only other conversion factors you got to know besides this one is time. How many seconds in a minute? How many minutes in an hour? How many hours in a day? And if we can't do that, we are in really bad trouble. But otherwise, I will give it to you. Okay, I will see you on Wednesday.